Okay, we're live, and welcome to another VJug session. It gives me great pleasure in introducing to you guys Mr. Gavin King. Gavin, how you doing?
Hi, Gavin.
Hey, everybody.
And welcome to the VJug, your first session. And obviously with us, as always, is Oliver. Oliver, how you doing?
I'm very well, guys. I'm excited about learning a little more on Ceylon, one of those elusive JVM languagues. We wrote an in-depth report, let's see, a while ago, Simon, didn't we, on the Adventurous Developer's Guide to JVM Languages, and Gavin was kind enough to participate in that. So maybe as a reminder, we can pop out that report to anyone who's interested, and they can download it.
Absolutely, that sounds great.
Sounds reasonable.
Yeah, I think Anton from Zero Turnaround wrote a little bit about Ceylon. I think he took the Ceylon language. We all took one, right?
Yeah.
So
yeah.
let me just show you what's coming up. So for those of you who don't know Gavin, Gavin is the lead of the Ceylon project at Red Hat. And for those of you who have heard of this new upcoming ORM called Hibernate, I think it's called. Quite a few people use it now. It's just starting to pick up traction, I believe. Gavin was the creator of Hibernate as well, so we've got a lot of experience already under Gavin's belt, and it's a true privilege to have again such great speakers at the VJug. Just to let you know, then coming up, let's share my screen again and actually make it work this time. Screen share, entire screen share. Okay, so this is what we have coming up. We have Ceylon today. The video for last week's session on Groovy is already up, so you're welcome to view that again. In just a couple of days, on December 11th, we have another JVM language session on Kotlin, and then next week is our final session of the year, which is Scala for Java developers. So this is our fourth and final JVM language that we're going to be covering this year. This is the last set of sessions this year. After that, we will be, or should I say, toward the end of this week, we are going to be putting up, hopefully, fingers crossed, the session in January, which is going to be with James Gosling. And that will be on January 22nd, so really proud to have James on as well. And very much looking forward to hearing from James. So without further ado, couple of things, actually, one more thing that I will say. For those of you, any discussions, drop it straight in IRC on #virtualjug, and you can put discussions and questions in there. I'll pose questions directly to Gavin, and yeah, Gavin.
Cool.
Go for it.
So thanks, guys. Thanks for having me here. This is my first time, absolutely first time doing anything like this. So we'll see how it goes. I'm a little nervous. So again, thanks for having me here. It's exciting to finally get the chance to get out there and start telling people about what we've been working on for really quite a few years now. So I'm just going to get into it. After a quick disclaimer, namely that people often people can sometimes react negatively if I kind of make comments about Ceylon and in comparison to Java or in comparison to some other language. I want to say, look, we're everyone on my team are huge fans of Java, of the JVM, of other of having multiple languages on the JVM. There are lots of programming languages that we like. If I criticize something or if I seem critical of something in some other language, it's not a bash. It's to kind of identify things that can be improved, identify differences, justify, why we might have done something a little bit different in Ceylon. I'm going to start off some slides before we get to kind of the something a little bit more code oriented. If I switch to the slides here. So what's Ceylon? What is it? Well, it's a programming language, duh. It runs on virtual machines. To be specific, it runs on the Java VM and on JavaScript VMs. This is not, a programming language for systems programming. It's not in the same place as, C, C++, Rust, what have you. It's a language defined by specification. We think that's something that's very important. The correct behavior of the language is not, what the compiler does, it's what's written down in the spec. It's a language that has a syntax that, deliberately looks quite conventional and familiar to someone who's used a language that descends from, from C or from Java. But that, if you see some Ceylon code on a blog somewhere, it's, most likely that you're going to understand it even if you don't know Ceylon. But that conventionality kind of hides, the fact that the syntax is actually very flexible and a lot more flexible than, say, Java, for example. It's a language with a very powerful type system. A very, the word people often use to describe the type system is an elegant type system, and that's like an explicit goal of the type system. It's a language with built-in modularity. From my point of view, modularity is something that's kind of central to everything we do as developers. It's a central notion of the whole discipline of software engineering. And traditionally, surprisingly, languages have featured, rather poor support for modularity. It comes with its own language, with its own SDK, its own modular SDK, a set of modules which, eventually provide you, all the basics to start, writing programs and applications. And the core of that is something we call the language module. It's a very small module that kind of fills the role that, say, Java Lang and bits of Java util fill in the Java ecosystem. And this is cross-platform and kind of abstracts away from the specific VM that we're executing on. It's a language with, I think we're confident to say, really excellent tooling. Tooling for us, the purpose of having a language with static typing is to be able to, define and provide, excellent tooling. So, where can I use this? Where does this language run? So I can use it on Java SE, in combination with the Ceylon module runtime, which is a very small module container based on JBoss modules, which is a very minimal, kind of the minimal core of JBoss AS. This is not to say that Ceylon has anything to do with JBoss. It's just we reuse this small module container. It can run alternatively in any OSGI container. The Ceylon compiler produces modules that come along with OSGI metadata, so you can deploy a Ceylon module in Eclipse, in Apache Felix, Wildfly, or Glassfish. For example, we know this works because we've written parts of Ceylon IDE in Ceylon, and we deploy those modules in Eclipse and as OSGI modules. It will run over on the JavaScript side of the fence. It'll run on Node.js, and the modules appear as JavaScript modules, which you can load using Node's require function, or even in a web browser if you use a common JS modules implementation like require.js is the one you might have heard of, you might have used. On the other hand, if you want to use the Node model of the Node programming model, the Node concurrency model on the JVM, you have the option of Vertex. Vertex comes with native built-in support for Ceylon modules. You can deploy Ceylon modules directly on Vertex, and it knows exactly what it's doing with that. Finally, we're in the next release we'll have support for running a Ceylon module as a var in a Java servlet engine via a command line tool which repackages the Ceylon module as a var. the first question anybody asks me when we start talking about, a language for the JVM is, what about interop with Java, or when we're talking about the JavaScript VM, what about interop with JavaScript? So there's two ways you can go about, kind of building a module in Ceylon. First, you could use it to build a cross-platform module that will execute on either of the virtual machine environments, in which case you depend only on other cross-platform modules which are also written in pure Ceylon. Alternatively, you can write a Ceylon module that targets, one of the two virtual machines, in which case you can interop with native Java or JavaScript code. You can even, package native Java and JavaScript code, together into your module, or you can, call out to, Java modules, that you get from, from Maven or from somewhere else. I'm talking about Java jars. Obviously, for statically typed language, one of the interesting, one of the really interesting challenges is interoperation with a dynamic language like JavaScript. So, this was something which, we had to address, very, very, very explicitly. So, there's two ways to interoperate with JavaScript in Ceylon. One is via dynamic typing. We have a special language construct called dynamic, which kind of turns off the type checker, not completely, within a particular block of code, and lets you make calls that wouldn't be well typed, because you're calling a JavaScript API that Ceylon, that doesn't come with types. The Ceylon compiler can't validate the calls you're making, and the type checker will let it through because it's in a dynamic block, and then at runtime you might get type errors. An alternative approach is you can write an interface in Ceylon, we call it a dynamic interface, that adds static type information to a JavaScript API. Finally, my last slide is, people often ask, well, what's special about this language? Surely it can't possibly have anything else. Which, there's lots of languages which run on the JVM. Surely it can't possibly have anything that's really unique. And so, the fact of that is it's simply not true. There are a bunch of unique things about Ceylon, but I'm going to quickly run through several which are easiest to understand. First of all, it's a language designed from the start for multi-platform use. The language and language module really extract away from the details of the virtual machine. So you don't see constructs which are uncomfortable, which are coming from Java and Java's type system of the Java virtual machine when you're running on JavaScript. So the notion of other virtual machines is really a core concept in the design of the language. Second, when running on any of these on either VM, you have reified generics. That is reification at runtime of generic type arguments. And this comes along with a type-safe meta model, which is something really unique. The notion that ordinarily, if I'm in Java or something and I obtain a meta model object, or an object that represents a method or a function or something within the Java program, I get back something that's lost all type information about the program element it refers to. In Ceylon, that's not the case. If I obtain an object that represents a function, first of all, that process of obtaining it is type safe. It doesn't involve, passing strings around, and then what I get back captures the type the signature of the function this meta model object represents. Finally, this meta model provides access to generic type arguments. So these are, features which go kind of hand in hand. Next, union intersection types. This is really, the coolest thing about the language. Union and intersection types, sound cool when you first hear about them. Pretty soon, it becomes difficult to understand how you could have felt comfortable writing code without them. They came into the language because they form the foundation of a couple of things that were very important, that we identified as very important. Type inference without ambiguities in a system, in a type system with subtyping. That's something which, has been difficult for other languages. Other languages haven't really been able to provide. And flow-sensitive typing. We're going to see these things, in a couple of slides. But really, once you have union intersection types there, you just discover that they're much more useful than you could have possibly imagined. Something else that's kind of special about Ceylon is the way that we represent function and tuple types in a way that allows abstraction over arity. So we represent a function type. There's a single interface callable which represents generically represents any kind of function, and a single class tuple which generically represents any kind of any tuple arity. So we avoid the explosion of single method interfaces that you see in Java 8, or the kind of function 1, function 2, function 3, and matching tuple 1, tuple 2, tuple 3 up to some arbitrary limit of 22 or whatever that you see in some other languages. And the point of this is it allows abstraction, which we'll see right at the end of this presentation. The point of all this is that we take a point of view of having a simple, unified type system, a powerful type system, but a simple type system, and then we provide syntax sugar over that to help kind of reduce the verbosity and improve rather than harm readability. So that's the guiding philosophy there. So I'm going to start. What the rest of this presentation is going to do is present a set of kind of very small code examples. That's not to say that every problem we can tackle with Ceylon is small. The problems are big problems that we're interested in. But these small problems are the problems I can fit the code on my slides. So let's consider something that really is something which comes up quite often, and that's the idea of a function which has multiple outcomes. For example, let's imagine a parse function that accepts a string, and it might return a file, or it might return a URL, or it might not return anything because the string doesn't have a valid syntax. So how might I do this in Java? Well, first of all, if it could return a file and a URL, these two classes don't have any interesting supertype in common. So I guess I'd make the function return object. I could handle the case of nothing to return, the case of a syntax error with a null value by returning null, but that's something I generally, lots of the time, prefer to avoid in Java because there's nothing in the type signature of a Java function which indicates to the caller that null is a possible outcome of the function. So in this case, I'm going to throw an exception, a syntax exception. Then to call this function, well, what do? I call the function. I get back an object. I have to test if it's a file, if it's a URL. We look. Well, if it is a file, then I have to typecast the result to file. And there, we see the first thing that's kind of a little bit crazy. There's very few uses of instance of that aren't immediately followed by a typecast to the tested type. But almost every language on Earth forces me to go ahead and explicitly do that, introducing the possibility that I might make a mistake, and introducing needless verbosity. Then I do the same thing with URL, another typecast. Then I use try catch to catch the exception. And what's wrong with this? I guess you might say that this looks all right. Well, what's wrong with it is that there's no way for the compiler to help me know if I've handled all the possible outcomes of that function. If somebody changes parse path to return some other kind of object in addition to file and URL, this code doesn't break. So the compiler just doesn't have enough information to help me know that I've handled all the outcomes. How would I do this in Ceylon? Well, we can define the notion of a function with more than one outcome using a union type. So here I have a function, parse accepts a string, and returns a file or a path or a syntax error. this syntax file or path or syntax error is just a type expression. Okay, this is an ordinary type within the type system. When you see a type like file or path or syntax error, we're in a type system with subtyping. So the questions that arise are, well, what are the supertypes of this type? What are the subtypes of this type? The answers are the subtypes of this type are obviously, the set of all types which are assignable, which are subtypes of file or of path or of syntax error. The supertypes are, include any type which is a supertype of file and of path and of syntax error. Okay? Now, from the caller side, we can handle the various outcomes using a switch. Here I call parse path, and I get back a result, and the compiler is able to tell which of the cases I need to handle: file, URL. I don't have to do typecasting because there's a notion of flow sensitive typing when I do when I handle that within this case block, result is automatically narrowed to file or to URL. Now, union type help us even further in this case. For example, I can aggregate cases together using a union type. I can even use if instead of switch to achieve much the same kind of effect. Now, you might think that this is this is somewhat of a contrived thing, something we don't do all the time. Well, okay, on the contrary, one special case of this is something we do all the time. The example is retrieving an item from a map. This get method of the map interface is a function which we can return multiple outcomes. It accepts a key, and it either returns an item or returns nothing. And the way we write that in Ceylon is maybe item. This question mark we pronounce maybe. So maybe item literally means null or item, where null is a class. So let's go and start writing some code to make this a little more concrete. So there's an object in Ceylon in the Ceylon language module called process, and it gives me access to the command line arguments of the virtual machine, and I can just get the first one, assign it to a value. All right, now let's say I want to print a message. So hello. Right. And look here, I've got an error. So it says a right argument must be a compatible summable type. Maybe string is not assignable to string. All right, so to understand this a little bit better, I'm going to tell you what plus means. Plus means this, all right? Where this method plus is defined. I've written on string. But it's defined by this interface summable. So summable is an interface which abstracts over types which have an addition operation. And obviously this is an interface you can implement yourself. So now we can see that this is an argument for a method, and the method has accepts a string, and obviously we have something that's a maybe string. All right. So let's see what that means. Well, remember what we said. That meant. It meant null or string, right? Okay. So let's use a type assertion to narrow the type of arg to the thing we think it should be. So this narrows the type of arg to string. We've used an assertion. This is the closest thing the language has to a typecast. It's a typecast. It just comes with a slightly clearer syntax. So now you're looking at this and exists, and you're like, wow, this is a whole some new extra construct. Well, this is just syntax sugar. Okay, what this means what exists means is object, right? So it's a type test. Right? We've already seen some type tests on the previous slide. Now you might ask, if I had something, which was a maybe string, and I asserted that it was a type object, how did I get down here to it having the type string? It's interesting because the thing to know about this is that the Ceylon compiler doesn't throw away information. So we already knew that arg was a maybe string. All right, and we know what that means. It means null or string. Don't worry about these pointy brackets here. These pointy brackets are just grouping. So this ampersand means is an intersection type. So I have something that I know is an object, and I know it's either null or string. Now, intersection distributes over, intersection distributes over union. So that previous type expression was equivalent to this type expression, object and null, or object and string. So let's look over here, object and null. What could that mean? Well, let's go and have a look at null. So null is a class. It's an enumerated class, which is to say it has only one instance, this object null. Okay, so null is an object in Ceylon's type system. Perfectly ordinary object written in Ceylon. Null extends a class called anything. So if we go over here, we can see, well, this is the abstract supertype of all types. And it has two subtypes, object and null. Now we can see that these are disjoint types. So null, you know, we've already seen what subtypes it has, just this object null, and object has, well, it's the supertype of essentially everything else. So when we see this, we now know that object and null are disjoint types. So if I have an intersection between two disjoint sets, I get the empty set. In Ceylon, we write the empty set, nothing. Over here, well, we just saw that string was a subtype of object, right? So the intersection of a subset with a superset is subset. Now I have a union between the empty set and something, so I know I have a string. That's exactly the reasoning that the Ceylon compiler does. We did it, you know. It took some time about doing that to understand how it reasons, but essentially, you know, this is something that, you know, the Ceylon compiler slices through like you know, easily and just doesn't get tired. It's designed to handle this kind of reasoning, you know, just easily and cleanly. So you know, back to my slide. The point. You know, the point behind all this is that null is part of our type system. It's not a special purpose case, you know, engineered into the language spec as a whole in the type system. We can't write things in Ceylon that would produce a null pointer exception. Those kind of things are type errors. You know, but on the other hand, you know, obviously because maybe types are so common, we have a bunch of syntax sugar for dealing with them delicately. Let's see another case where union types help us somewhat. So let's consider the example of instantiating an array list. All right. So you know, let's suppose I have an array list, and for some dumb reason, this is contrived, I know, but it represents some things that actually, you know, do happen in practice. I have an array list of integers and floats, and you know, the question here is, you know, what type of list do I have here? In Java, I would be forced to write, you know, write what type of list I have on the other side. You know, in some other languages, perhaps I could, you know, say that, well, you know, object or something. But the trouble is that integer and float can have, you know, because I have a type system with multiple inheritance, they have, you know, multiple supertypes in common. And how do I, you know, uniquely determine, you know, which of those supertypes I should, you know, unambiguously determine which of those supertypes I'm interested in? So you know, the answer to that is, if I, you know, if I just write in the type arguments explicitly, the answer is integer or float. Integer or float is the most precise common supertype of both integer and float. the fact that we can do this in Ceylon, the fact that the type system of Ceylon forms a lattice, allows us to eliminate these kind of ambiguities in type inference. So then over here, the eventual type I get out of this is an array list of integer or float. Again, this might seem a little bit contrived for this particular example, but now we're going to see where it actually, I should say, then what's the type of an element of this list? If I get the second element of this list, what I have is null or integer or float. Null corresponds to the case where this is out of bounds, integer or float. This square bracket syntax just means it's syntax sugar for the get method of list. And the point about this is I have unambiguous type inference without any loss of precision. So let's see some real examples of this. So the interface iterable in Ceylon is our abstraction of streams. Iterable has a method called follow, which essentially adds an element to the start of the stream. We have some syntax sugar for dealing with iterables, these curly braces with a star or a plus is just some syntax sugar that you'll very quickly get used to. And when I form a stream, passing some strings, I'll get back a stream of strings. And then if I call this function follow and pass it a null, I should get back a stream of strings and nulls. And so as you can see here, I'm using union to assign the correct type to that method. In this code examples down at the bottom, I don't have a pointer here, I'm explicitly writing in the type so that you guys can see how this works. I could have written value and let those types be inferred because the compiler, there's no ambiguity in any of this. The compiler is able to reason and determine what is the correct type there. Intersections and streams, we have a different, one of my favorite functions is the coalesce function. Coalesce eliminates null elements from a stream. And so if I have a stream of elements and I coalesce them, then I get a stream of things which are element and object. Remember that null and object were disjoint. So then if I pass coalesce a stream of maybe strings, I get back a stream of strings. Again, everything could be inferred here because the compiler is rather great at reasoning about these kind of types. Right, now we get to a problem that's interesting. And this one had us stumped for literally years. If I have a type system where null is statically typed, where null, with no null pointer exceptions, when you come to contemplate the problem of the signature of max or min, you run into a problem. Max can evaluate to null, or there is a case where it doesn't have, where it doesn't evaluate to a value. But that's only in the case where the stream might be empty, where we don't know in advance that the stream has at least one element. So one, potential signature we could try for max would be to accept a stream and return a stream of values which are comparable, and return a maybe value. That's going to work, but we're going to be annoying, every time almost always when the users call it, when the program is calling max, they know that they have a stream with some values in it. So we're going to be forcing them to then go and assert that the stream's non-empty. So the question is, what if we know it's non-empty at compile time? Do we go and write a separate function max of non-empty? Right, which accepts a known non-empty stream and returns a value which is not a maybe value, and then we have to have a min non-empty and all these functions. I mean, that just sounds terrible. This is going to be the worst language on earth. So the solution we went for is to give iterable a second type parameter, this type parameter absent. And you can see that the type constraint on absent is rather strange. It says that absent must be a subtype of null. But we've already seen what were the subtypes of null, right? No subtypes of null is just a single instance of null. So what could this possibly mean? We have to, the question we ask ourselves, well, is there any other subtypes of absent other than null? Well, here there is. If you guys remember, there's nothing. Okay, nothing, the empty set, is a subtype of every type. The empty set is a subset of every set. So there's two possible values for the type arguments to the type parameter absent, null and nothing. And what could they possibly signify? To see what they signify, we need to go down and look at first. Remember first? We already saw first when we grabbed the first argument from process.arguments. So we look at the signature of first. It claims to return an element or an absent. So in the case where absent is null, then this is just maybe element, right? So that would correspond to the case where the stream might be empty, where we don't know at compile time whether the stream is empty or not. If absent is nothing, then element or nothing is just element. So we know, we know that first is going to return a value of type element. This corresponds to the case where we know that at compile time that the stream is non-empty. Okay, so now we understand how to use this absent in our max function to propagate the value of absent, and we get a max function that automatically determines, returns the right type, making use of what we statically know at compile time about the stream we're passing to max. So if we pass an empty stream to max, we get back null, a known empty stream. If we pass a known non-empty stream, hello world, to max, we get back a string. If we pass a stream which we don't know whether it's empty or not, then we get back a maybe string. Again, I don't have to write in these types. These types can be inferred. I'm writing them in so you guys can see them. All right. Now let's change from talking about union and section types and start talking about, start thinking about a different problem. Function, we talked about a function which might return x or y. Now let's think about a function with multiple return values, which returns an x and a y. So an operation here which returns a protocol and a path. It parses a URL accepting a string, and then it returns me back a protocol and a path. If I were to do this in Java, I would have to define a class. So back and we ask, well, what's wrong with that? Nothing. It's okay. It's fine. A lot of the time, that's the best thing to do. I've never been I've never thought that this was, a very bad thing at all. However, there are times when it's inconvenient to have to, write a class just for, one function which I'm just using locally or whatever. And there are times when it's convenient to not have to write a class that just, has an x and a y. So in Ceylon, I can use a different solution. I can return a tuple. So these square brackets in Ceylon construct a tuple, and we can write a tuple type with square brackets, and then we can, in a type-safe way, extract the elements of the tuple. And I think so. Let's look at back over here. Excuse me, what that really means. So let's say I have a tuple containing a string, hello, a float, a couple of floats. I don't know. I'm just making stuff up here. So I have a tuple. Its type is string, float. We can see that tuple of 0 is a string, right? Tuple of 1, 2 is a float. You can see that the compiler determines all that. Once you're like, wow, now you've gone and engineered tuples into your whole type system. I thought you said that was you had a type system that was simple. Well, I also told you that we have a single class tuple here. Now, quite a simple class, really, and relatively easy to understand. Notice that the implementation of this class uses, all kinds of, uses unions and features that Ceylon makes easy. So let's look at what this means, string float float. So as we can see, this syntax sugar for tuple types is just syntax sugar that refers to some disgustingly complex type under the covers. This is a disgustingly complex type from my point of view as a human reader looking at that and trying to understand what it says. But for the Ceylon compiler, it's far easier to reason about this than it would be to reason about the special case of tuple types. And so that's the way the compiler does it. Then let's look down at what this means. Well, this means, first, if we look at first on tuple, returns the first element of the tuple. And over here, this means rest first. Okay, so you can see that even where we have these this nice syntax sugar to make it easy to write code with tuples, actually under the covers, tuple is just a class. You could write your own tuple class, and it would be able to do all the same thing. What about if I use an index that's out of range? So let's say tuple of 10. That's out of the range. What's its type? Null. That's correct. Something to note here is that it's legitimate to use these square brackets because a tuple is just a subclass of list. A tuple is just a kind of a list. What happens if I had an unknown index I here? And I would get back null or string or float, which is the same type I would get back for a list. So you can see cool relationships there. Now let's consider the problem of passing a tuple to another function. So suppose I have a function called get, which accepts a protocol and a path, and I have a tuple containing a protocol and a path. Then what I'd love to do is, like in Groovy, or you can do a similar kind of thing in JavaScript, is kind of spread out the arguments of that tuple over the parameters of that get function. So let's see over here. I have a string, a float, and a float. So let's write a function quickly over here. I don't know, going to return an integer. I don't really know. Fun. It accepts string float x float y, and I don't know, it returns silly. Okay, so what I would like to do is take my tuple and pass it to fun, and the way I'm going to do that is using a spread and. And you can see that that's well typed. What would happen if over here I had only a string and a float? Then this is an error. So we can start to see that there's a deep relationship between tuple types and function types. And we can take advantage of that even at the level of function references when we're doing functional programming with higher order functions. I can compose get with parse URL using a higher order function called unflatten. So these tuple types make it possible to reason and write code at a meta level with function references. So let's consider the problem of the compose function. Compose composes two functions. In most languages, it would have a signature like the one you see there. It would take a function that accepts an A and returns a Y, and another function that accepts a Y, the output of the first function, and returns an X. And it gives me back a function that accepts an A and returns an X. Now that's all well and good, but this is not quite as general as it could be, all right? For functions with just one parameter, like composing print with square root to get a print square root function, it works well. But what about functions with multiple parameters? What about if I compose print and plus? Well, with that definition, I can't, because plus is a function with two parameters. So in Ceylon, the function, the type of a function is an instantiation of the interface callable. So callable has two type parameters: return, obviously that's the return type of the function, and arguments. And arguments is a sequence type, okay, or typically a tuple type. And so arguments captures the type of the parameter list of the function. So I can abstract over the type of the parameter type of the function in my compose function. And you can see, this looks obviously a little complex to someone who's had approximately half an hour looking at Ceylon code and has never seen any Ceylon code before that. This looks a little complex and ugly, all right. But remember, we've in half an hour gone from hello world to function composition, and so you can see that what we've done here is write a function which composes a function with an arbitrary number of arguments, with an arbitrary number of arguments, with a function that accepts its return type and returns a different type. So this stuff, potentially doesn't seem that useful to you guys at first sight, but the truth is, it turns out to be much more useful than you expect. We use this in various places. For example, a type-safe meta model that I talked about, is founded on this. It's founded upon the ability to be able to abstract over function types. If I, get a, if I go and get a meta level reference to fun, which I write like this, and so this is a meta model reference to fun. What I have here is an instance of the interface function, which you can see abstracts over the signature of fun using the same approach. And that's my slides. So if we want to go to some questions, I'm very, very, very happy to do that.
Right, it takes about 60 seconds for the live stream to catch up with the everyone else. So we're pitching some questions in here. Let's see. There's lots of happy faces in this IRC chat. So
we're getting a lot of love for union types, a huge amount of love for tuples, as you'd expect. We have a couple of questions to start off with. One from Pioneer. Actually, this is from a while back. CommonJS does not equal require.js. Which one is actually used? And also one from Hamid, saying Ceylon uses the JVM Nashorn script, a JavaScript engine, question mark.
Can we go one at a time? So the difference between, CommonJS does not require JS, but the modules we produce are CommonJS modules, and require is able to load them. I think that's the answer to that. I don't know beyond that what the question is referring to, and I might not even know the answer. I don't maintain the JS compiler myself, but all I know is that the modules we produce are able to be loaded in both Node and by require.js and by other CommonJS implementations, as far as I know.
Okay, a couple just coming in, which are very, very similar, about Ceylon exceptions. Does Ceylon throw tuple return types? I guess more like a reactive kind of way.
Ceylon obviously has an exceptions model that's very, very much very similar to Java's exceptions model. We use it relatively less. It's not an ideological thing to avoid. Well, it kind of is. We avoid exceptions for certain kinds of things which traditionally programming languages have used exceptions for. That is to say, we don't have array index out of bounds exceptions, right? So we don't use exceptions to handle the case of an array index out of the list of indexes of a list. We don't use exceptions for. We don't have exceptions for null pointers. This corresponds to the fact that Ceylon is a relatively stricter type system than in languages like Java and other languages. It is a fussier type system. It's a stricter type system. Potentially, you might think that if you have a type system that's so fussy, that would get in your way. We counter that by providing you, if you have a static type checker that's stricter, you need to, that gets in people's way more. You need to, on the other hand, if you're taking away from people, you need to give them back abilities to abstract and abilities to solve their problems. And so, we do that. Essentially, what I would say is that Ceylon kind of challenges you to do things in a more satisfying way. It challenges you to do things in a way that takes advantage of the type system, rather than I'm going to throw an exception, or rather than I'm going to stick in a typecast here, right?
Mm-hmm. One more. How does Ceylon interoperate with Java? Because I guess this is, as new languages are created, it's one of the utmost importance to interop with Java.
So Ceylon interoperates, very well with Java. We put a lot, truly an immense amount of effort into the problem of Java interoperability. We could have delivered the Ceylon compiler probably a year and a half or even 2 years earlier if we wouldn't have put in all the work to have the Ceylon compiler generate Java classes with all the generic type information in them. Okay, so that from a Java client seeing a Ceylon class, it can see the generic type information in that class. We invested an enormous amount of effort into this. It's not. On the other hand, abstracting away from the VM comes with some costs. There are, Ceylon strings are not Java strings. They are automatically converted between in some situations, where that's sound to do without implicit type conversions. So there are cases where other languages do interop more, I don't want to say cleanly, but more simply. Because they abstract away from the VM less. However, I still want to say that, even taking that into account, our Java interop is excellent, and it's a pleasure to write code which uses both languages.
Okay, cool. And then moving on to performance, and I guess I can extend the question slightly, given what we just talked about.
Mm-hmm.
So the question is, how does Ceylon perform compared to a Scala or a Clojure or a Node? But I can extend that slightly just to say, given you are pulling away so much from the, I guess, the Java type system, there's going to be an amount of a performance here as well in that type mapping.
Yeah, there is. Look, I mean, first of all, again, compared to Java, for very many things we have performance which is essentially, the same as Java. We use Java C to generate our bytecode. The way the Ceylon compiler works is to take a Ceylon AST, transform that into a Java C AST, hand it off to Java C to let Java C generate the bytecode. Okay, this is a lot of work to do it this way, but one of the advantages is that the bytecode which is generated by Ceylon is very much like the bytecode that Java C itself would generate. And so, if it were Java, right, well, it's identical. It is the same bytecode. However, again, when you come to talk about collections, you have a slightly that's a bigger topic. In general, because of our abstraction away from the array types of, we don't have, well, we do, but we don't have in the language module, int array, float array, long array. We have a single array type, and that is, kind of a little abstracted away from Java's array type. Because of that, Ceylon's collections in micro benchmarks perform a little worse than Java's collections. We're not talking about differences that you're going to see in real code, but we're talking about differences that will pop up in micro benchmarks. If you run into a case where that is a problem in practice, what you can do is use Java util list, right? Or use a Java int array. You can import java.base, and then there's a type you'll get with java.base. That's the module which represents, the base module of Jigsaw. Then you'll get a type which represents a Java int array, a type which represents a primitive Java float array. And you can use those directly. Of course, you will have lost portability to a different VM, right? But you will be able to take advantage of that performance. And so, essentially, from my point of view, there are some things, collections which are a little slower, a little slower. But you can work around that, in really performance critical code by going back to the native Java types.
Awesome. And another question from Despair, the same guy. Does Ceylon have a REPL available? And this is interesting because, of course, Java's going to be...
We don't have a REPL, and, I'm sensitive to the fact that, people enjoy using REPLs. My take on this is you guys have seen me how I write code in a run method in my IDE and just run it, and to me this is better than a REPL. Whenever I'm using a REPL, I find it an absolute pain because normally, I want to create a class, and I have to do that, and then if I want to make a change to that class, I have to go up, copy the whole definition of the class back into the thing, change it, and enter again, and I find the whole experience of working in a REPL for anything other than adding numbers together, anything other than using a REPL as a calculator, I find it an immense pain and far inferior to what you saw me doing today of just, I have a function, run, and I just type code in there and run it. And that's, to me, far superior.
Mm. And so you think the Java REPL that's coming in is wasted effort then, or?
I mean, do people really in Java really use bean shell? I mean, I know that some do occasionally, but I've never found a moment in my life when I felt I needed bean shell. I mean, I think the desire for a REPL, I also understand that perhaps my needs are different to others, and my way of working is different to others. I'm very IDE-oriented, but to me, the desire for a REPL comes from people who are using languages which don't have IDEs. To me, people who write code in Eclipse or IntelliJ or what have you don't reach for a REPL because there's no need for it. Perhaps I'm wrong. I'm not hostile to somebody creating a REPL for Ceylon. And in fact, our online code runner that you can go and run some Ceylon code, write some Ceylon code in your web browser and run it is almost like a REPL. So you could almost say that that we do have a REPL. We have the online web runner thing for Ceylon, which is a lot like a REPL.
Awesome. We have one last question. We're just reaching the top of the hour, so this is good timing. From Pioneer, what are your plans regarding JavaScript VM? Do you plan to use your own idiomatic front-end framework like Angular, or maybe instead to have better integrations or wrappers around JavaScript libraries?
So what we're thinking about, I don't think that we have one strategy, right? I think we're providing a programming language, and I want our user community to experiment with various different approaches. I think, one of the first things we're looking at doing is to take we have a notion in the Ceylon compiler of a model loader. A model loader is something which takes some input and generates the model which represents the types in that input and lets the type checker do what it wants with it. What we're looking at doing is creating a model loader for TypeScript. Microsoft have done a lot of work in TypeScript to create a bunch of schemas for all the common type schemas for all the common JavaScript APIs, and that's a lot of work, and it's it's great work, and we should be able to reuse that and leverage that to to take advantage of that information that's in those schemas within the Ceylon compiler. And you recall I talked about having dynamic interfaces. So in Ceylon we have this notion of a dynamic interface, something which ascribes types to a JavaScript API. And instead of having those written in Ceylon, we should be able to just reuse TypeScript's schemas. So that's the strategy we aim to follow. Yeah.
Okay, awesome. So we don't have any more questions in IRC at the moment. So what I'm going to do is I'm going to say if anyone has further questions but doesn't have time to add them in, please comment on the meetup event, and I'll pass those comments across over to Gavin. And if you're watching this on replay, do feel free to comment afterwards on the meetup.com/virtual-jug. Find the event, comment it on there. We'll get a notification and I'll pass that on to Gavin. One final question that I'll ask, Gavin. So if people wanted to learn more, try it, where do they go? What's the next steps?
Yeah, so I mean, go to ceylonlang.org, and there's a tour of the language, which essentially explains almost the whole language, and have a read of that. Also, come on our IRC channel, which is #Ceylonlang on Freenode, and there's people there almost the whole day. I'm not sure about Australia time, but there certainly is in European and US time. There's people there, and it's very active, and people are asking questions there about Ceylon and getting answers all the time. So that's really a great tool for us. Obviously you can ask questions in the mailing list. So.
Awesome, thank you very much, Gavin. And it's really interesting to see the kind of differences that between a language like Ceylon and Groovy that we saw last week. How Groovy does stay very, very close to the Java language while trying to remain syntactically nicer and just a nicer language to code, whereas Ceylon really has taken the innovation and really kind of pushed different boundaries. And there are certainly some things in Ceylon which I would absolutely love for them to exist. Certainly Tuples, for example, Tuples. That would be amazing. It reminds me of my old kind of struct days in C++ about 10, 15 years ago. But so thank you very much, Gavin, for giving us that masterclass in Ceylon. And next to our VJUG members, our next VJUG session is on Thursday, and that's to talk about Kotlin, which is in the similar kind of age as Ceylon. In terms of the length of time it's been developed for, and also I'd say it holds that kind of distance away from Java in the thinking of how it was created, and it's not been afraid to really break the boundaries in having different styles of development. So that's this Thursday around the same time, 5 o'clock GMT. And that's everything for now. So I'll say thank you very, very much to Gavin for an awesome masterclass.
Good seeing you.
And this video is now available already for a replay, and I'll post that into IRC, and that'll be available on Twitter as well. So till next time, thank you very much, VJuggers, and have a great evening.
Bye.
Bye.